All right, so on number 1, it asks us to change the given function from vertex form to standard form. And while the instructions might sound a little bit confusing, in reality, all you have to do is go ahead and simplify this function. So since this x plus 2 is being squared, I can rewrite that as x plus 2 times x plus 2, and then I will still have to add the 3 at the end. So I'm going to go ahead and distribute, and x times x is x squared. X times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4, and then I still have my plus 3. So then when I simplify this, I have x squared, and then my 2x and 2x are like terms, so those can be combined to 4x, and my 4 and 3 can be combined to 7, and this is now written in standard form. Number 2 is asking to go from standard form to vertex form, so it's asking me to go reverse order from the one I did above. And this one takes a few more steps to accomplish. So in order to put it in vertex form, which is right here, I have to find what the vertex is. This axis of symmetry formula gives me the x value of my vertex, so I'll start there. First, I need to know what a, b, and c are. So a is the number in front of x squared, b is the number in front of x, and c is our constant number. Notice that the a, b, and c only include the number portion, they don't include the variable. So when I find the axis of symmetry, I have a negative b, which is a negative 18, over 2 times a, which is 2 times 3, which is a negative 18 over 6, which simplifies to a negative 3. So I have the x value, or h value, of my vertex, which is negative 3. To find this value, I just need to plug this negative 3 in for x and solve. So I have 3 times a negative 3 squared plus 18 times a negative 3, and then minus 5. A negative 3 squared is 9, so now I have 3 times 9. 18 times a negative 3 is a negative 54, and then minus 5. And then 3 times 9 is 27, minus 54, minus 5 is a negative 32. So the y value, or k value, of my vertex is a negative 32. So then I can go ahead and write it in this form right here. So I start with f of x equals, and then my a value is right here, so that's 3. And then I have x minus a negative 3, so that would be plus 3 squared, and then minus this 32. And that is the same function but written in vertex form. On number 3, it's asking me to find the maximum or the minimum. The maximum and minimum is the same thing as your vertex, which we just found on the previous problem. On part A, this is already written in vertex form. So this is my h, and this is my k. So I don't even have to go through the process of finding them because they're already given for me. One thing I need to remember, though, is that in vertex form, which I'll go ahead and write right here so that we remember, it has a minus h. So since this is plus h, that would plus 5, that would move it left 5, so my vertex is actually at a negative 5, 7. And then in order to tell whether it's a maximum or a minimum, this is a quadratic function, so it's shaped like this. All it has is a minimum, so this would have to be a minimum. Whereas this one has a negative out front, which would flip the graph over the x-axis. All it has is a maximum, so this one would have to be a maximum. On part B, I have to actually go through and find my vertex by finding the axis of symmetry. So I start with the negative b over 2a, so a negative negative 8 over 2 times a negative 1. So this double negative gives me a positive 8. 2 times a negative 1 is a negative 2, and then 8 divided by a negative 2 is a negative 4. So I now have the x value of my vertex. When I plug this in for x, I have a negative 4 squared minus 8 times the negative 4 plus 3. So negative 4 squared is 16, but then I have this minus out here, so I have a minus 16. Negative 8 times a negative 4 is a plus 32 plus 3. And then negative 16 plus 32 plus 3 is equal to 19. So my vertex is right here. My maximum is at negative 4, 19. Number 4 is about finding types of functions, equations for parent functions, and transformations. So this asks for 3 different things. So make sure you read the instructions and complete everything it asks for. So the first thing is the type of function. Since this is being squared, this is a quadratic function. So the equation for the parent function is just the equation before any transformations are made. So in this case, it's y equals x squared, or f of x equals x squared. And then transformations is how the graph has moved. So this 2 out front stretches the graph vertically. So I would say there's a vertical stretch of 2. Then the minus 7 on the inside moves it right 7. The plus 5 on the outside moves it up 5. And then this side, since it's taking the square root, this would be called a root function, which can be rewritten as, the parent function can be written as y equals the square root of x, or f of x equals the square root of x. Now this function has a negative on the inside of the function, which means it flips over the y-axis. If that negative were on the outside of the function out here, that would flip it over the x-axis. But these do the exact same thing that we had over here. This plus 3 would move it left 3, and the minus 7 would move it down 7. And that's the first page of your review done. So now we'll move on to the second page, which starts with stating the number of real, complex, and total solutions. So to know the total number of solutions, you just look for your biggest exponent. So this one has a 3, a 2, and then a 1. So 3 is the highest exponent, so there are 3 total solutions. I then want to find which solutions are real, and that's where it crosses the x-axis. So here, here, and here. So that is 3 real solutions. And if there's 3 total and 3 are real, then there's none left to be complex. And then the same with part B, the biggest exponent is a 2. So there are 2 total solutions. But this graph doesn't cross the x-axis at all. So there's 0 real solutions, 2 complex solutions. Complex, we could also say imaginary. So if the word imaginary is used instead, don't let that throw you off. Numbers 6 and 7 are dealing with domain and range from looking at a graph. So if I start here with number 6a, domain goes from left to right and range goes from bottom to top, because domain is our x values, range is our y values. So to find the domain, I look what's the furthest left my graph goes, which is this point right here, and it's at negative 1, 2, 3, 4. So the furthest left it goes is negative 4. The furthest to the right it goes is negative 1. And then the only thing I have left is to decide whether I use brackets or parentheses. And since these circles are filled in, they're included in the graph, and I would use brackets. And then the range is the same idea, but I'm going from bottom to top. So the lowest this graph goes is a negative 2, and that's part of the graph, so I'll have a bracket. And the highest it goes is a 2, which is also included on the graph, so it has a bracket. Part B is the same idea, except we've got these arrows here. And the arrow means it keeps going and going and going forever. So if I'm looking at domain, I'm starting at the left, I don't know where it starts because this keeps going forever and ever and ever. So I'm going to write this as a negative infinity because it's coming from the negative side forever and ever away. Whereas this side, the furthest right it goes, is positive direction forever and ever and ever. So this would be a positive infinity. And because infinity is technically not a number, you can never include it. So it doesn't get brackets, it just gets parentheses. And then range, I go from my lowest point, which is right here, at a negative 3.5, and it's included on the graph, so it can have a bracket, but it goes up forever and ever and ever. So from negative 3.5 to infinity. End behavior is exactly what it sounds like. We just want to know how our graph is behaving at the two ends. So if I start here, as x goes to infinity, so as x is getting bigger and bigger and bigger this way, y is getting higher and higher and higher, so it's moving towards infinity. Whereas x is going to negative infinity, the graph is going lower and lower and lower and lower to a negative infinity. All right, so now we have the very last page of your part A of your review. So on number 8, it's asking for the interval in which the function is positive. The biggest thing to remember in problems like this is we are looking at x values. So I want to know what the x value intervals are for where this graph is positive. A graph being positive is where it's above the x-axis. So right here is above the x-axis, and right here it's above the x-axis. So it looks like I'm going to have two intervals. And again, just like we did with domain, we're going to go from the left to the right. So since this keeps going, my first positive interval starts at negative infinity and goes until x equals 0. So my first interval is from negative infinity to 0. Then my second interval starts at 2 and goes on to infinity. So from 2 to infinity, the graph is positive. Number 9, again, I'm going to go from left to right, but instead of looking for where the graph is positive, I want to know where it's increasing. So if I start on the left-hand side, this is decreasing, 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 decreasing until here. Then it starts to increase, 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 increase till here. So this is the interval I'm looking for. But remember, I'm looking at x values. So some people are tempted to say from -3 to 4, but those are y values. So that's not what I'm looking for. The x value at this point is -1.5. And then the x value at this point is 2. So it's increasing from -1.5 until 2. Numbers 10 and 11 both deal with inverse functions. 10 is dealing with their graphs, and 11 is with the equations. So on numbers 10 and 11, we need to know what are some of the points that are on this graph. So this graph has a point at 0, 1. It has a point at 2, 3. And it has a point at -1, 0. So in order to graph the inverse function, the inverse just has the x and y values switch. So my inverse function would have a point at 1, 0, at 3, 2, and at 0, -1. So if I go ahead and graph those points, I have a point at 1, 0, 3, 2, and 0, -1. And if I connect those points, that is my inverse function. So it's the same idea on this one. This one has a point at -4, 0, a point at 0, 2, and then a point at 5, 3. So then I find my inverse points at 0, -4, 2, 0, and 3, 5. So if I go ahead and graph those, I have 0, -4, 2, 0, and 3, 5. And if I connect that, there's my inverse function. On 11, A and B, it's a similar idea, but I'm given an equation instead of a graph. So f of x can be rewritten as y. So I could write this y equals 4x plus 7, and then just like I did with these points, I'm going to switch the x and y. So x equals 4y plus 7, and then solve this equation for y. So I minus a 7 from both sides. X minus 7 equals 4y, and then divide both sides by 4. So I have x minus 7 over 4, and that is my inverse function, which is written like this. And then part B works the exact same way. So I'm going to have you try this one on your own to save time and go on to number 12. So number 12 is asking for rate of change, and the two values it gives you here are x values. So it wants the rate of change from where x is 0 to where x is 1. And rate of change is your slope, so that's just rise over run. So if we look here, this goes down 4, so I have a -4, and over 1, over 1. So this is equal to a -4. And I'll go ahead and let you try 13 on your own.